We've talked about the concept of unit testing throughout the course. We wrote some pretty simple unit tests for some of our assignments. But it turns out that testing is actually a full-on industry, and there are much more sophisticated testing suites available to you. There's a unit test package built into Python, but we needed some prerequisites first. We needed to understand classes, and we needed to understand how to import modules into our program. We have that knowledge now, so we're ready to go. We're going to import the unit test package, which is already installed in Python for you. We are also going to import one of our own modules, currency converter. And because that name is super long, I'm going to give it an alias. I'll call it CC. We are going to write our own custom test class, but we're going to inherit from a class called test case, which is included in the unit test module. So we'll write class testcc for our currency converter, and in parentheses, the name of the class we want to inherit from. So that's unittest.testcase. Each method that we add to our custom testing class will be run as a test automatically. Let's go look at the currency converter function and see what we might want to test. The currency converter function takes three parameters: a quantity of currency as a float, a source currency as a string, and also a target currency as a string. The source and target currencies should be in this conversions dictionary. And this function returns a float, which represents the amount of currency converted to the target currency. So some things we might want to test are, what happens if we submit a currency that's not in the dictionary? Or what if we put in an invalid quantity like 0 or a negative number? And we'd also probably like to test that the currency converter gives us accurate results when we do put in valid currencies. Let's start with the first possibilities. We'd like to make sure that our currency converter raises an exception properly in certain bad cases. So for instance, the user passes a bad currency. This method doesn't need to take any parameters other than the self parameter. And we're going to use something called a context manager, starting with the keyword with, and we'll use one of the methods that's included in the test case class. When we type self and then dot, we see a whole bunch of methods that are available to us. We're just going to explore a couple. And the first one is assert raises. So we are asserting or claiming that this function should raise a certain error. And the error that we're looking for is a key error. After we enter the context manager, we just call the function. Remember, we've aliased currency converter as CC. That's the module name. The function name is currency converter, and it takes three parameters. We're going to enter a correct first parameter, but then an incorrect second parameter, some currency that's not in the list. And then the third parameter, we're going to include a currency that is in the list, New Zealand dollar. We haven't talked about a context manager, and it's really beyond the scope of this class. Using the context manager with the assert raises method allows us to write the function call out in a much more familiar way. We'll copy this and write it again, but this time entering the incorrect currency in the second position. We mentioned a couple more tests that we want to do. What happens when the user enters a 0 or negative number as the quantity? Again, we're expecting an exception to be raised, so we'll use the context manager. I'm going to copy and paste. This time we're really expecting a value error, but I want to show you what happens when we get an exception that we're not expecting. So I'm going to leave key error here, put in a negative number, and I want to make sure that both of the currencies are correct so we don't get confused by two different errors. Next, we want to make sure that our function is actually returning the values that we're looking for when we pass it valid arguments. In this case, we don't need to use the context manager. We're going to use a method called assert equal. It simply takes two arguments and lets you know whether they're equal or not. The first one should be your expected value, and the second one should be some sort of calculated value. In this case, we want to run our currency converter function. And we're going to ask currency converter to convert 10 US dollars to British pounds. So unit test is going to call this function, get a result, and compare it with the number 8. I'm going to copy and paste this twice more. For my second test, I'm going to convert Canadian dollars to US dollars. I'll convert 1 Canadian dollar, and I've calculated that that's about 71 cents in US dollars. And finally, I will convert euros to US dollars. I'll start with 1.8 euros, and I should get $2.8. Now I'm ready to run this code. I'm going to use the if name equals main pattern. Now I haven't actually written a main function, and I'm not going to. There's one included in unit test, so instead of typing main here, I'm going to type unittest.main to call the function that's already written. And it's time for me to admit to something. I've left a problem in our currency converter module. You see, there's some testing code that I had there. When I run the module in the context of the currency converter, it asks me to convert euros to dollars. So if I type in 10 euros, it says 10 euros is $11.11. And that's fantastic. But when I go back to my unit test function and try to run this, I still get this test. How many euros do you want to convert to dollars? And that's because in the currency converter function, I wrote this code at the unindented module level, and it got executed when I imported currency converter. So just the fact of importing the currency converter function caused my code to get executed. I didn't want that to happen. I need to put this inside a main function and then add the pattern if name equals main. And now if I run this from the currency converter context, I get my test code. But if I run it from unit test, the test code is not executed. So that's good. So let's see what we did get. PyCharm notices that we're running the unit test module and gives us this convenient pane on the left. It shows the test results that we ran from this unit test module. And inside, it gives us a line for each test that failed. We had 3 tests and 2 of them failed. We see that the test bad currencies method did not show up in the list, so everything was fine there. Test non-positive quantity showed up in the list because the method raised a value error when we were expecting a key error. Of course we knew that. We put this in so that we could see what would happen if we got the wrong error. So let's just change this to value error. We'll run the test again. And that method no longer shows up in the list. There's another cool thing about this left pane here, and that's that we can run continuous testing. There's a button that says toggle auto test. If I click that button, then the test will run every time I make a change to my currency converter function, so I can see exactly when everything's working okay. We have one last problem method, and that's this test return values method. On the first line, we expected a value of 8, but when we ran the currency converter function, we actually got a value of 12.5. That's because I built in a little bug to our currency converter function. This second line in the conversion should be multiplication instead of division. Watch the run menu as I change this. The test is automatically run again, and that first error goes away. The result was now correct. We still have errors from this method, however. On the second line, we have an expected value of 0.71, but an actual value of 0.714285714285714.3. That's because when I did the calculation by hand, I rounded off to 71 cents. The function, of course, tries to give us a more precise value. The solution here is to use a method called assert almost equal instead of assert equal. When it runs again, it still says there's a problem because almost equal is checking to 7 decimal places. Almost equal has a third parameter, which is precision, and we're going to tell it to check to 2 decimal places. It'll auto run again, and then that function is fine. And our last call shows a problem because I accidentally put United States dollars instead of Canadian dollars. So let's fix that here. And now our 3 tests show up okay. The unit test package is not the only package for testing Python programs. There are plenty more third-party packages that are free. But unit test can take you a long way. Again, if you just type self and then dot, you can see how many assertions there are. We have some Boolean assertions. We can compare greater than or less than, equal to, in, is, all of the comparisons that you're familiar with. I hope you take some time to explore this package and see how it can help you track down problems quickly.